Good evening, students. Today's section we are going to discuss about the last unit of this course, Process Control Engineering, which is about the non-linear systems. Okay, so far whatever we are discussed is about the linear system, but when you take a practical real world problem, each and every problem will be a non-linear system. Okay, so in this unit we'll explore what is a non-linear system and what are the different type of controller implemented for this kind of non-linear systems. So what is a nonlinear system? So before knowing what is nonlinear system, let us first explore what is a linear system. Okay, a system which obeys a superposition principle, a system which is homogeneous, that is called the linear system. Okay, so you can see here there is a set of input is given to a system and you will get a set of outputs. Okay, say for example you have a input u1 to um and the respective output as y1 to yp. Okay, so for example, let us take a two input, two output system. If you give a two inputs, say U1 and U2, you should get the respective output Y1 and Y2. Okay, so when you can say a system is linear, when the linear combination of input is equal to the linear combination of output. The linear combination in the sense alpha times U1 plus beta times U2 should be equal to alpha times y1 plus alpha times y2. Okay, so that is called as a superposition principle. Okay, suppose, what do you mean by I hope you are clear about what is a linear system, right? So once once you could able to classify what is a linear system, then coming to a non-linear system. Okay, so non-linear system is nothing but classifying an So here you can see that the linearity can be represented in the first graph. This is one of the example where if you see that relationship between the voltage and current. Okay, so if you see in case of a diode, as there is increase in the current, there will be increase in the voltage also. Okay, sorry, as there is increase in the voltage, there will be increase in the current also. Okay, so this is a forward bias and this is a reverse bias. Okay, this linearity characteristics is similar to the characteristics of the PN junction diode. Okay, and if you see the other two cases, it is a non-linear system. Okay, now coming to the classification of non-linearity. Okay, so you can classify the non-linearity on the basis of magnitude or on the basis of frequency. Okay, so if you take a magnitude, you can classify as a incidential non-linearity and intentional non-linearity. Okay, incidential nonlinearity is present inherently in the system, whereas intentional nonlinearity is where you are inserting the nonlinearity to modify the system characteristics. Okay, another one is classification based on the frequency. So in your syllabus, it is restricted up to the classification based on the magnitude. Okay, so based on the magnitude, we classify the nonlinearity as different type: dead zone, saturation, friction, backlash, relay. Okay, and based on the frequency, limit cycle, jump resonance, frequency entrainment, beat frequency production, self excitation, harmonics, and chaotic behavior. Okay, coming to the classification based on the magnitude, first one is a dead zone. So dead zone. Okay, so dead zone is nothing but, as I hope in the first unit we have studied about dead time. Okay, so dead time is nothing but the time for which the output takes some time to respond to the given input, that is called the dead time. Okay, similarly dead zone is nothing but the period between the tolerance band, that is minus delta to plus delta, that is called dead zone. Okay, so if you take this dead zone, the element will remain dead, that is it don't respond to the given input. After it, once it reaches the tolerance level, then it is going to either increase according to the characteristics of the device. Say for example, if you take a same characteristics, PN junction diode, if you take a VI characteristics, if you take a PN junction diode, the diode made up of a silicon, after zero point 0.7 voltage only it starts, the current will start to conduct. And similarly, if you take a germanium, after zero point 0.3 voltage only it is going to have a conduction. Okay, in both the forward bias and reverse bias. Okay, so this period after the threshold or after the dead tolerance band, you call that as a dead zone. Okay, so the output is zero until the magnitude of input exceeds a certain value. Such an input output relationship is called as a dead zone. Okay, the same the another example represented here is a DC motor. In ideal case, we assume that any voltage applied to the armature welding will cause the armature to rotate with a small voltage causing a small motion. But practical case, a small voltage is not required, cannot be able to drive the motor. Okay, so in that case, a motor, the rotation will occur only if the torque provided by the motor is sufficiently large. So this dead zone is called as a inherent nonlinearity, where the nonlinearity is present. It is instantial nonlinearity, where the nonlinearity is present inherently in the system. Okay, if you take a dead zone, number of the possible effects on the control system. Okay, it decreases accuracy as well as it leads to the instability. Okay, so if you see that it makes the system performance degradation, reduce the accuracy and may destabilize the system. Okay, so to overcome this, as I said, one of the example is a electronic devices like diode. The diode will exhibit the dead zone. Okay, this is one of the nonlinear element. Another element is a saturation. Saturation is nothing but the element will remain linear for some period, and once it reaches the maximum value it remains constant. Okay, that is called saturation. Say for example, if you take a xenodiode, the xenodiode can act as a regulator, so it is going to keep on increasing. Once it reaches a maximum level, it is going to remain the constant. Like if you see, if you take a voltage regulator, whatever input you will get, it is going to maintain a steady output, that is constant output. That is called as a saturation dead zone. Okay, when one increases the input to a physical device, the following phenomena is observed. When the input is small, it increases, lead to a corresponding increase in the output. But when the input reaches a certain level, it further increase does produce little or no increase in the output. The output simply stays around its maximum value. This is called as a saturation. Okay, another type of this saturation also will lead to instability. Another example they represented here is a output torque of two-phase servo motor, which cannot increase infinitely and tend to saturate due to the property of magnetic material. Okay, this is another example representing the saturation characteristics. Coming to the next nonlinear element is a friction. I hope you have studied in your physics friction. Friction is nothing but when two bodies are in motion. Okay, there will be a friction is exerted, but it is nothing but the force exerted between the two objects in contact that are moving relative to one another. Okay, so friction is depend on the relative speed of the two objects. Okay, so the common example is electric motor is, we find the Coulomb friction drag due to the rubbing force between the brushes and the commutator. We have a two type of friction. One is a static friction, another one is a dynamic friction. Static friction is the friction which acts on the body when the body is at rest. This is dynamic friction is the friction act on the body when there is a relative motion between the surface and the body. The force exerted by the friction is due to Coulomb friction, viscous friction and stiction. Okay, all these forces depends on the speed. Okay, so if you take the characteristics of the friction, you can see this diagram representing the Coulomb friction, stiction, viscous damping. So all are added together to get a friction. Okay. The next type of nonlinear element is a backlash and hysteresis. Okay, so backlash is mainly occurring in the transmission system. It is caused by a small gap when there exists a transmission mechanism. In a gear train, there always exists a small gap between the pair of mating gears due to unavoidable error in a manufacturing and assembly. Okay, so this is also incidental nonlinearity which is present inherently in the system. Okay, as a result of the gap, when the driving gear rotates a smaller angle than the gap B, the driven gear does not move at all, which corresponds to the dead zone. Okay, after contact has been established between two gears, the driven gear follow the rotation of the driving gear in a linear fashion, that is the AB segment. When the driving gear rotates in the reverse direction by a distance 2b, the driven gear does not move. You can see here corresponds to the segment BC segment in the figure. Okay, so you can see that there are two gears, mating gears. One is a driven gear, another one is a driving gear. Okay, so you can see that there is a gap between these two gap between the two gearing assembly, and that is due to the dead zone nonlinearity. Okay, so here sorry, hysteresis nonlinearity. Okay, so here initially it is going to form a segment from A to B, then B to C, then C to D, then D to E. Okay, so it is going always, the driven gear is in periodic motion. The driven gear will move in a fashion E, B, C, D. Okay, and this leads to a hysteresis or a backlash nonlinearity. Okay, so this purely depends on the amplitude of the input sinusoidal signal. Okay, and coming to the, okay, so corresponding to each input, two output values are possible when one of the two occur depend on the history of the input. Okay, so this is called as a hysteresis, and this is mainly due to instability and self-sustained oscillation. Another one nonlinearity is a on-off nonlinearity. It occurs when the linearity range is shrunken to zero and slope in the linearity range become vertical. Okay, so if you see that the dead zone is shrunken and it is leading to there is no slope, and it is vertical. Okay, and of course in most of the gas jets for a spacecraft control and in electrical relays, on-off nonlinearity is mainly this on-off nonlinearity will lead to a chattering and discontinuous in nature. Okay, and coming to the next one, next type of nonlinearity is called as a negative temperature coefficient. It is one of the characteristics of the principle behind the thermistor. Okay, so thermistor is one of the temperature transducer which works on the principle of negative temperature coefficient. Okay, so here it is you can see that it is made up of oxides of iron, manganese and magnesium, etc. The characteristics can be studied using RT is equal to R naught into e power beta times 1 by T minus 1 by T naught, where RT is a resistance at temperature T, R naught is a resistance at temperature T naught, T naught is a reference temperature normally maintained as 25 degrees Celsius, and beta is a constant value whose value is nominal value is 4000. Okay, so from this, the temperature coefficient can be represented as alpha T is equal to 1 by RT into dRT by dt. Okay, so this is inversely proportional to resistance. So if you see the characteristics of the thermistor, you can see that as there is an increase in the temperature, there will be a reduction in the resistance. That's why you call this as a negative temperature coefficient. This leads to a non-linear negative temperature coefficient which give rise to the error due to the self-heating effect. Okay, so this non-linear characteristics of thermistor can be taken into account. One of the characteristics is a negative temperature coefficient. Okay, another one is limiters. Okay, so limiter is a device which is going to limit the signal. Okay, so in most of the control systems we need all physical values are limited. It is useful to have a limiting devices in the control system. For, say for example, if you take a charger, okay, so once battery is full, it has to limit the supply. Okay, so it has to maintain the constant or steady value. The limiters are represented as y6 static nonlinearity, which is y is represented as ul or u or uh. It depends on the value of the control signal. U less than or equal to ul, u lies between ul to and u greater than or equal to Okay, so this is used to limit the rate of change of signals. Okay, so this is called as a rate limiter. And similarly we have a mm, jump and rate limiters. Okay, so the rate limiter will always have the integrator, and you have a jump limiters also. So different type of limiters can be used in case of a to avoid the integral wind up in a PID control. This is one of the application where you use the amplitude limiters. Thank you, students.